So, hello student. In today class, we discuss about the new chapter inverse trigonometric functions. In the last class, we have discussed about the trigonometric function. Now, there was three chapter left in the trigonometric function related to trigonometric function. First is inverse trigonometric function. Second is hyperbolic function. Third is properties of triangle. Now I'm starting one more chapter that was inverse trigonometric function. Inverse trigonometric function. Trigonometric function. So these type of function are generally the inverse of trigonometric function. Suppose let sine theta is equal to x, then theta is equal to sine inverse of x. But inverse is exists only in two cases. Inverse exists only if they are if the function is 1 and onto. That means the function will be bijective. Okay, you know that all trigonometric functions are onto because range of the function belong, belongs to them. Just a minute, wait one minute. Now let us suppose sine theta is equal to x. The domain of sine theta belongs to um, minus pi by 2 to pi by 2, and the range of sine theta belongs to minus 1, sorry, just a minute, wait, just a minute. The domain of sine theta is always real number, and the value of x is from minus 1 to 1. So if you see the graph of sine theta, here is 1, here is minus 1. So you always get the graph of sine theta like that. 0 to pi by 2. Now at pi, 3 pi by 2. Okay. So if you take any horizontal line, so it will cut in many parts. That means it was not 1 and on. It was not 1 because it is failing horizontal line test. What the horizontal line test tells us Horizontal line test tell us that if you take horizontal line and it will cut the graph more than 2 points, then it is not 1 1. If it cut in only 1 point, then it is 1 1. Now, for making it 1 1, we will take it from pi by 2 to minus pi by 2. This is pi by 2. This is minus pi by 2. In this graph, minus pi by 2 to pi by 2, you can take any number of horizontal line, then you will get only one value of sine theta. That's why the value of sine theta will be domain of and in this part minus pi by 2 to pi by 2 sine theta is 1 1 and on 2. That's why we are taking the domain of sine theta is from minus 1 to 1, and the range is from minus pi by 2 to pi by 2. In that part, it was 1 1 and on 2. Okay, and if you find sine inverse x, then the domain, then the range of the function will become domain, and the range of the function will become minus 1 to 1. Now we have to remember the range of n cos inverse x, which is also equal to 0 to pi and minus 1 to 1. Only you have to remember two things. Later, if tan inverse x has came, cot inverse x will came. So we will discuss in that part. Okay. Now I'm discussing some important formula of trigonometric function. First is, we know that in the trigonometric function, sine minus theta is equal to minus sine theta. Cos minus theta is equal to cos theta. Tan minus theta is equal to minus tan theta. Cot minus theta is equal to cot theta. Cosec minus theta is equal to minus cosec theta. Sec minus theta is equal to sec theta. Now in trigonometric function, if minus sign is come inside sine inverse, then you will get minus of sine inverse x. Cos inverse minus x is equal to pi minus cos inverse of x. Tan inverse minus x is equal to minus of tan inverse x. Cot inverse of minus x is equal to pi minus cot inverse x. Cosec inverse of minus x is equal to minus cosec inverse x, and sec inverse of minus x is equal to pi minus sec inverse of x. Always remember CCS formula. CCS. C for cos, C for cot, C for cos, C for cot, and S for sec. They became sorry. They do different behavior than other trigonometric function. Let's see in sine minus theta is minus theta, and here cos minus theta is cos theta. Tan minus theta is minus tan theta. Again, see cot minus theta is cot theta. Cosec theta is equal to minus cosec theta, and cosec minus theta is equal to minus cosec theta, but sec minus theta is sec theta. Means these three functions are showing different behavior than other function. Similarly, in inverse trigonometric function, sine inverse minus x is minus sine inverse x, cos inverse minus x is pi minus cos inverse x, tan inverse minus x is minus tan inverse x, and cot inverse minus x is pi minus cot inverse x. Cosec inverse minus x is minus cosec inverse x, and sec inverse minus x is pi minus sec inverse x. So these are the formula of trigonometric function. Now In trigonometry, we have discussed three formulas or other of squares. Sin square theta plus cos square theta is equal to 1, and 1 plus tan square theta is equal to sec square theta. 1 plus cot square theta is equal to cosec square theta. But in trigonometry, in inverse trigonometry, there are the three formulas. Sin inverse x plus cos inverse x is always equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Sec inverse x plus cosec inverse x is always equal to pi by 2. And now, in trigonometry function, we also discussed that sin theta is equal to 1 upon cosec theta. C is inverse of S and S is inverse of C. Okay. C is inverse of S. 1 upon sec theta, tan theta is equal to 1 upon cot theta. And also cosec theta is inverse of sin theta. Sec theta is inverse of cos theta. Cot theta is inverse of tan theta. Now in inverse trigonometry, sine inverse of x is equal to cosec inverse of 1 upon x. Sec inverse of x, cos inverse of x. Cos inverse of x is equal to sec inverse of 1 upon x. Tan inverse of x is equal to cot inverse of 1 upon x. And cosec inverse of x is equal to sine inverse of 1 upon x. Sec inverse of x is equal to cos inverse of 1 upon x. Cot inverse of x is equal to tan inverse of 1 upon x. Now all the trigonometric function can be changed in that. How? You can see that if sine inverse x is equal to x, then what it means? That means sine is perpendicular upon base. So perpendicular upon hypotenuse. This was is perpendicular, and we don't know hypotenuse here. So we can take here one as hypotenuse. Perpendicular upon hypotenuse is sine inverse x. We know that perpendicular square is equal to hypotenuse square plus base square. Perpendicular square is x square is equal to 1 square plus base square. So base square is equal to x square minus 1 square. Okay. So base is equal to under root x square minus 1. X square minus 1. So from here, we will get the value of cos inverse. So sine inverse x is equal to x upon 1, which is equal to cos inverse of cos inverse is base upon hypotenuse. What is base? Under root x square minus 1 upon hypotenuse is 1. Also, we can write it as in terms of tan inverse. We know that tan inverse is perpendicular upon hypotenuse. Perpendicular is x, sorry, perpendicular upon base. Perpendicular is x and base is under root x square minus 1. So tan inverse is x upon under root x square minus 1. We can also write it in the form of cot inverse. Cot inverse is base upon hypotenuse. What is base? Under root x square minus 1 upon x. We can also write it in the form of sec inverse. Sec inverse is hypotenuse. Hypotenuse is 1 upon base under root x square minus 1. We can also write it in the form of cosec inverse. Cosec inverse is hypotenuse upon perpendicular. That means 1 upon x. That's why I have written sine inverse x as cosec inverse 1 upon x. So in that way, we can change a function from one part to another part. Now next, come to the next formula. In trigonometry, we have discussed the formula of sin A plus B, sin A minus B, cos A plus B, and cos A minus B. So the formula of sin A plus B is sin A cos B plus cos A sin B. The formula of sin A minus B is sin A cos B minus cos A sin B. The formula of cos A plus B is cos A cos B minus sin A sin B. The formula of cos A minus B is cos A cos B plus sin A sin B. Now the formula of sin inverse x plus sin inverse y became sin inverse x plus sin inverse y is equal to sin inverse x under root 1 minus y square plus y under root 1 minus x square. The formula of sin inverse x minus sin inverse y became sin inverse x of under root 1 minus y square minus y times of under root 1 minus x square. Now next, cos inverse x plus cos inverse y. So which is equal to cos inverse of xy minus under root 1 minus x square into under root 1 minus y square. Now next formula of sin inverse. Sin inverse x plus cos inverse x minus cos inverse y. So cos inverse x minus cos inverse y is equal to cos inverse xy plus under root 1 minus x square and under root 1 minus y square. So these are the formula of sin inverse x plus sin inverse y and sin cos inverse x plus cos inverse and cos inverse x minus cos inverse y. Now we have discussed the formula of tan. So tan a plus b will be tan a plus tan b, tan a plus tan b upon 1 minus tan a tan b, and tan a minus b is tan a minus tan b upon 1 plus tan a tan b, tan a minus tan b upon 1 plus tan a tan b. Now the formula of tan inverse x plus tan inverse y will become tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus of xy. Now the formula of tan inverse x minus tan inverse y will become tan inverse of x minus y upon 1 plus xy. Okay. Now the formula of sine to theta we have discussed there in the trigonometry, which was became 2 sine theta cos theta, or 2 tan theta upon 1 plus tan square theta. And the formula of cos 2 theta is cos square theta minus sin square theta. Second formula is 1 minus 2 sin square theta. Third formula is 2 cos square theta minus 1. Next formula is 1 minus tan square theta upon 1 plus tan square theta. And the last one, the formula of tan to theta is 2 tan theta upon 1 minus tan square theta. 1 minus tan square theta. Now, the formula of 2 sine inverse x. So 2 sine inverse x is equal to sine inverse 2x under root 1 minus x square, or cos inverse 1 minus 2x square. Okay. Now next formula of 2 cos inverse x. 2 cos inverse x is equal to cos inverse of 2x square minus 1. And the formula of 2 tan inverse x is tan inverse 2x upon 1 minus x square. Next formula is sine inverse 2x upon 1 plus x square. Next formula is cos inverse 1 minus x square upon 1 plus x square. Now, three-angle formula. First is sine 3 theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. And the formula of cos 3 theta. Cos 3 theta is 4 cos cube theta minus 3 cos theta. Tan 3 theta. Tan 3 theta is equal to 3 tan theta minus 10 cube theta upon 1 minus 3 tan square theta. Now 3 sine inverse x is equal to sine inverse 3x minus 4x cube. 3 cos inverse x is equal to cos inverse 4x cube minus 3x. 3 tan inverse x is equal to tan inverse of 3x minus x cube upon 1 minus 3 x square. Okay. So student, that's our your formula. If we have forward any formula, then we see that formula in the questions. Now I'm discussing all the previous year questions of inverse trigonometric function that have come in your Telangana and Andhra Pradesh board. Okay. So the first question is, prove that sine inverse just prove that tan inverse 1 upon 2 plus tan inverse 1 upon 5 plus tan inverse 1 upon 8 is equal to pi by 4. Now I'm solving this question. taking LHS, taking LHS. So tan inverse of 1 upon 2 plus tan inverse of 1 upon 5 plus tan inverse of 1 upon 8. So tan inverse A plus tan inverse B will become tan inverse A plus B upon 1 minus A into B plus tan inverse of 1 upon 8. Now if you take LCM, so you will get tan inverse of 2 into 5 is 10. So 5 plus 2 upon 10 minus 1 upon 10 plus tan inverse of 1 upon 8. Now 5 plus 2 is 7 upon 10 and 9 upon 10. So tan inverse 7 upon 10 and 9 upon 10. So 10 will be cancelled by 10 plus tan inverse of 1 upon 8. So you will get tan inverse 7 upon 9 plus tan inverse 1 upon 8. So tan inverse A plus tan inverse B is tan inverse A plus B upon 1 minus AB. So tan inverse LCM of 9 and 8 is 72. 8 7 is 56 plus 9 upon 56 minus 7 upon 72. Now this will be cancelled. So the value will become tan inverse 56 plus 9 is 65 upon 56 minus 7 is 56 minus 7 is just a minute. 56 plus 9 is 65. Sorry, here will be a 72. Just by mistake. Written 56. 72 minus 7. So 72 minus 7 is also 65. Now 65 will be cancelled with 65. So tan inverse 1. So tan inverse 1 is equal to pi by 4, which is equal to the RHS. Now next question is, prove that sine inverse of 3 upon 5 plus sine inverse of 8 upon 17 is equal to cos inverse of 36 upon 85. Okay, solution. Now we have given that let I am taking sine inverse 3 upon 5 as A. Let sine inverse 3 upon 5 is A. So 3 upon 5 will become sine A. And similarly, I am taking sine inverse 8 upon 17 as B. So 8 upon 17 is equal to sine B. Now, cos A is sine A is perpendicular upon hypotenuse. So cos A will become perpendicular, sorry, base upon hypotenuse. So what is base? 5 square minus 3 square. That means 25 minus 9 is 16 and under root 16 will become 4. So 4 upon 5 and cos B will become 8 by 17. So you will get 15 upon 17. Now the formula of cos A plus B. So apply the formula of cos A plus B. Cos A plus B is equal to cos A cos B minus sin A sin B minus sin A sin B. So cos A cos B is equal to 4 upon 5 into 15 upon 17 minus sin A is 3 upon 5 into 8 upon 17. So you will get 85, 60 upon 85 minus 24 upon 85. So the value of cos A plus B will become cos A plus B is equal to 60 minus 24 upon 85, which is equal to 36 upon 85. So cos A plus B is equal to 36 upon 85. So A plus B is equal to cos inverse of 36 upon 85. A is equal to sine inverse of 3 by 5 and B is equal to sine inverse of 8 by 17. So sine inverse of 3 by 5 is equal to sine inverse of 8 by 17 is equal to cos inverse of 36 by 85 and proof. Now you have to solve sine inverse and cos inverse questions by that method. Let take them the value of A and B, then find the value of cos A and cos B, and now then you can solve these questions. Okay. Next question is tan inverse 1 by 7 plus tan inverse 1 by 13 minus tan inverse of 2 by 9 is equal to 0. Now, firstly, you will take these two values. So, you will get the value tan inverse 1 by 7 plus 1 by 13 upon 1 minus 1 by 7 into 1 by 13. On solving, you will get tan inverse, the LCM of 13 and 7 is 91. So, tan inverse of 91 plus, sorry, 13 plus 7, 13 plus 7, and in by you will get 91 minus 1 upon 91. So 91 will be cancelled. So you will get the value tan inverse 20 upon 90. Now cancel these two. So you will get tan inverse 1 upon 7 plus tan inverse 1 upon 13 as tan inverse 2 upon 9 minus tan inverse 2 upon 9, which was equal to 0. Just 10 inverse 1 upon 2 plus 10 inverse 1 upon 5. We have done that question. This question is repeated 3 times. Okay. Again and again, this chapter, then this question is repeating. Now the next question will be yours. Solve the following equation for x. 3 sine inverse 2x upon 1 minus x square minus 4 cos inverse 1 minus x square upon 1 plus x square plus 2 tan inverse 2x upon 1 minus x square is equal to pi by 3. Now solve this question. We know that 2 tan inverse x is equal to sine inverse 2x upon 1 minus x square. Next formula of sin 2 tan inverse x is cos inverse 1 minus x square upon 1 plus x square. Another formula of tan inverse x is tan inverse 2x upon 1 minus x square. So taking LHS, now sorry, we have to solve the value for x. So the equation is 3 sine inverse 2x upon 1 minus x square minus 4 cos inverse 1 minus x square upon 1 plus x square plus 2 tan inverse 2x upon 1 minus x square is equal to pi by 3. Now in place of sine inverse 2x upon 1 minus x square, you can put 2 tan inverse x minus 4 into cos inverse 1 minus x square upon 1 plus x square. You can put 2 tan inverse x minus 4 times of 2 tan inverse x plus the value of 2 this 2 tan inverse x upon 1 minus x square is equal to 2 into 2 tan inverse x. All are equal to pi by 3. So 3 to just 6 tan inverse x minus 8 tan inverse x plus 4 tan inverse x is equal to pi by 3. 6 plus 4 is 10 minus 8 is 2. So 2 tan inverse x is equal to pi by 3. So the value of tan inverse x will become pi by 6. So x is equal to 10 pi by 6. 10 pi by 6 means 1030, and value of 1030 will be 1 upon 1 upon root 3. Okay, what's your question? Now the next question is, again tan inverse 1 by 2 plus tan inverse 1 upon 5 plus tan inverse 1 upon 8 equal to pi by 4. Again the question is repeating. That question was your too much important for your boards because it is repeating again and again. Okay, so remember this question. Okay, now I'm finding some more important question. Next is, now the next question is your, if tan inverse x plus tan inverse y plus tan inverse y plus tan inverse z is equal to pi, then show that x plus y plus z is equal to xyz. Now see the solution. Then tan inverse x, let tan inverse x is equal to a. Let I am taking tan inverse x as a. So x is equal to tan a. Tan inverse x is equal to b. So b equal to, sorry, tan inverse x is equal, tan inverse y is equal to b. So y is equal to tan b. Tan inverse z equal to c. So z equal to tan c. Now a, b, c are the angles of triangle. So a plus b plus c equal to 180 degree. Because tan inverse x plus tan inverse y plus tan inverse z is given as 180 degree. So I am taking tan inverse x plus tan inverse y plus tan inverse z is equal to pi. So in place of tan inverse x, I can write a. In place of tan inverse y, I can write b. In place of tan inverse z, I can write c is equal to pi. So a plus b equal to 180 minus c. Now adding 10 both sides, multiplying by 10 both sides, so you will get tan a plus b is equal to 10 180 minus c. So 10 180 minus c is minus 10c, and tan a plus b is equal to tan a plus b upon 1 minus ab. So tan a plus b and 1 minus ab, which is equal to tan a plus tan b. Sorry, the formula I have applied here of tan inverse x plus y. So tan a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. We know that tan a equal to uh, tan a equal to x and tan b equal to y. So tan a equal to x plus y upon 1 minus xy is equal to minus the value of tan c is z. Now if you multiply, so you will get x plus y is equal to minus z or plus xyz. Now if minus z comes to our left hand side, so x plus y plus z is equal to xyz. So that was the solution of the question. Now next question is cot of sine inverse under root 13 upon 17 is equal to sine of tan inverse 2 by 3 to prove this part. Okay. So the solution came. Now taking cot sine inverse under root 3 upon 17, 13 upon 17. Yeah, add prove that, huh? We have discussed in the previous slide that sine inverse is if sine inverse is under root 13 by under root 17. So here 13 will be perpendicular and base will be under root 17. Sorry, hypotenuse will be under root 17. So hypotenuse square is equal to perpendicular square plus base square. Hypotenuse is under root 17 whole square is equal to under root 13 whole square plus base square. So under root 17 is 17, under root 13 is 13 plus base square. So 17 minus 13 is equal to base square. So base square is equal to 4. So base is equal to 2. So sine inverse is root 3 upon root 13 upon 17. So cot inverse is equal to base upon perpendicular. So base is 2 and perpendicular is under root 13. So cot of cot inverse is equal to 2 root of 13. So cot of cot inverse, we can write in place of sine inverse root 13 upon 17 as cot inverse 2 upon root 13. So cot of cot inverse 2 upon root 13 is equal to 2 upon root 13. So that was our LHS. Okay. Now I'm taking RHS. Sine is equal to sine tan inverse 2 upon 3. Taking RHS. Taking RHS. Sine of tan inverse 2 upon 3. Sine of tan inverse 2 upon 3. So tan inverse is perpendicular upon base. So tan inverse 2 upon 3 means 2 is perpendicular, 3 is base. So hypotenuse square is equal to perpendicular square plus base square. Perpendicular means 2 whole square plus 3 whole square is equal to hypotenuse square. So hypotenuse square is equal to 4 plus 9. So hypotenuse is equal to under root 4 plus 9, which is became 13. So if I change this to sine inverse, so sine inverse is equal to perpendicular upon hypotenuse 2 upon root 13. So sine in place of tan inverse 2 by 3, I can put sine of sine inverse 2 by root 13. So sine of sine inverse 2 by root 13 is equal to 2 by root 13, which is equal to your LHS, and hence prove that which is also became equal to LHS. Now we have proved that cot of sine inverse root 13 upon 17 is equal to sine of tan inverse 2 upon 3. Okay. So these all are the your questions of inverse trigonometric functions. Now in the next class, we will discuss if any other question is left. So I will discuss that question. If no other question will be left, so I will discuss hyperbolic function. Okay, that's all for today. Thank you, everyone.